Hello, folks, and welcome to another lesson. In this lesson in differential equations, I'm going to be going over another method to solving second order differential equations, and that is what's called variation of parameters. Variation of parameters. Okay, let's get started. So here is the overview. We're going to suppose we have a non-homogeneous second order differential equation, right? This is non-homogeneous. So we're going to have here a non-homogeneous differential equation. Okay. So far we know we know how to solve homogeneous differential equations like this, right? A times y double prime plus b times y prime plus c equals to 0, right? And so in this example, we're going to assume that a, b, and c are functions in t. Okay, are functions in t. So variation of parameters will have this formulation, right? Or we can let this have a coefficient of 1. So you'll see another formulation of this method written out like this. But it's just the same thing, right? We just restrict our domain where a of t is not 0, right? But nevertheless, we know how to solve homogeneous differential equations like this, right? And so the general solution of a homogeneous type looks like this, right? Our goal now is to figure out the constants, but this time the constants are in functions of t. So we want to look for what C1 equals to and what C2 equals to, right? So that is the goal of this section. Now, so we know that the homogeneous solution looks like this, right? For a second order linear differential equation, right? Existence and uniqueness, okay? Then if we differentiate y h of t, right, by the product rule, this is what's happening here. So by the product rule, y h prime of t equals to c1 of t times y1 prime of t plus c1 prime of t times y1 of t plus the derivative of the second quantity, right? c2 of t times y2 prime of t times c2 prime of t times y2 of t. So now we're assuming that this is the what would look like to be the general solution of solving equation one right here, right? So now we're going to assume that this quantity here, C1 prime times Y1 time plus C2 prime times Y2 equals to 0. So essentially these two terms in YH prime of t, okay? So that will reduce down to having the equation for YH prime of t equal to this quantity, right? C1 of t times Y1 prime of t plus C2 of t times Y2 prime of t, okay? Then if we differentiate YH of t again, YH double prime of t, so this one here. So if we differentiate this one equation here, YH double prime of t, well, it's going to be equal to the product rule again, right? So this quantity. So what we're going to do is if we plug in this function along with this function here into equation 1, what we're going to get is some formulation that looks like this, right? So right here, this is YH double prime of T. This quantity right here, this is, oh, oops, I went too far. So, so, so let me highlight. So this term right here, this is YH double prime. This term right here, that is YH prime. This term right here is YH, okay, YH of T. And it equals to capital F of T. I can't even fit it into the slide, but it equals to the function capital F of T, right? So what I'm going to do now is I'm going to gather some of the terms in this equation here. So what I see is if I factor this A term, what I will get is A times, I'll have this term right here along with this term. So I'll have C1 prime Y1 prime plus C2 prime Y2 prime, okay, as itself. And even though this looks daunting, a lot of magical stuff will happen in this equation, right? So C2 prime times Y2 prime, okay. And then I will have, so I'll have this term along with this term here with the Y1 prime of T and also with this term. So if I factor a C1 out onto those terms, I'll get A times Y1 double prime plus B times Y1 prime plus C times Y1. So that's pretty neat. Also, we're going to do the same thing with some other terms, the C2 term. So with the C2, we have, well, this A and then this C2 term here with this B and also with this other C2 term here and with this C and this final C2 term there. So if I factor a C2 out, we'll get the other variation, AY2 double prime plus BY2 prime plus C times Y2 equals capital F of T. Okay. Y1 and Y2 are solutions for the homogeneous equation. Homogeneous equation. Where was it? So Y1 and Y2 were solutions of this homogeneous equation, right? So what that means is this quantity right here has to be 0, and also this quantity right here also has to be 0. Okay, so what's left over is the first term, A times C1 prime Y1 prime plus C2 prime Y2 prime plus 0 equals to capital F of T, right? And so what we have is this quantity. We'll have C1 prime Y1 prime plus C2 prime Y2 prime equals to F of T divided by A of T, right? So this is the first equation that that we know. And also, we also know this, right? This is the other type of equation that we know. So we also know that C1 prime Y1 plus C2 prime Y2 is equal to 0, right? So these will be the system of equations that we will use in order to solve for the C1 function and the C2 function. Okay, so Now, if I erase just the majority of this work here, we are almost there to solving for what the functions C1 and C2 equal to, right? And let me erase this too. Okay, so this is the system of equations that we know. Okay, from the second equation, we can solve for, let's say, C2 prime. So what that will give us is that C2 is equal to minus C1 Y1 prime over Y2. Oh, I'm sorry. That's, I gotta be careful. The prime goes here. Y1 over Y2. So that's C2 prime. C2 prime is, yeah, minus C1 prime times Y1 over Y2. So we know that. And then by equation 1, right here, so we have C1 prime Y1 prime plus C2 prime. So we know that C2, that will equal to minus C1 prime Y1 over Y2 times Y2 prime. And this equals to the function f of t over a, right? Could be a constant, it could be a function, right? And so what this equals to is, so we'll have, if I factor a C1 prime out, I'll have a Y1 prime minus Y1, Y2 prime over Y2. And so this will be C1 prime times Y1 prime Y2 minus Y1 Y2 prime over Y2 equals to F over A, which means that C1 prime equals to F times Y2 over F times Y2 times A times Y1 prime Y2 minus Y1 Y2 prime. Okay. And since we know C2 prime is equal to this quantity, right? So we know that C1 is this. So C2 prime is equal to, so the Y2s will cancel, and we would get a minus F times Y1 over A times Y1 prime Y2 minus Y1 Y2 prime, right? Y2 prime. So here we have, let me erase this out of the way. So here we have the solutions for C1 prime and then C2 prime. So to figure out C1, all we got to do is just integrate that term, right? Fy2 over A times Y1 prime Y2 minus Y1 Y2 prime dt. And then C2 is just the integral of minus F times Y1 over A times Y1 prime Y2 minus Y1 Y2 prime dt. Okay, pretty straightforward, right? And notice, right, y1 prime, y2 minus y1, y2 prime. This was the Wronskian, right? This is how you compute the Wronskian of two solutions, y1, y2. This is what's called the Wronskian. Okay, so yeah. So um, yeah, so really you can just compute the Wronskian first of y1, y2, and just compute those integrals, right? Yeah, those are the Wronskian terms. Okay, so hopefully you noticed that. Yeah, so in summary, this is the method of solving a differential equation by using variation of parameters, right? So all you have to do is solve for the homogeneous differential equation for this equation here, right? These would be the solutions for the homogeneous equation, and then your work is to determine these your functions v1 of t and v2 of t. Okay, or that's the c1 of t and the c2t quantities that I just wrote out here, right? So, so this is the formula on how to compute those functions in detail. Okay, but let's go over some examples. Okay, so let's look at finding the general solution for this differential equation. Y double prime plus y equals to secant of t. Okay, so um, okay, so we want to solve for the homogeneous differential equation first. Y double prime plus y is 0. Okay, and then the characteristic equation would correspond to this equation, r squared plus 1 is 0. And so r is equal to plus or minus I. And so y h of t, this would equal to, yeah, so this is c1 of t times cosine t plus c2 of t times sine t. Okay, so that's the solution for the homogeneous equation. And then the next step is to solve for the C1 term and then the C2 of t term. Okay, so we know that y1, that is cosine t, and then y2 of t is sine t, right? So, and then secant is f of t, and then the a variable is 1, right? The number in front of the coefficient in front of the y double prime term, okay? So c1 of t, this would equal to the integral of secant of t times y2 of t, which is sine t, over the Wronskian. So let's compute the Wronskian of y1 and y2 if we don't know how to do those already. So y1 is cosine t and y2 sine t. So we have to look at the determinant of this matrix, minus sine t and cosine t, which is equal to cosine squared t plus sine squared t. This is 1. Okay, so the Wronskian is 1 over 1 times dt. And so this would equal to yeah, so that would equal to the integral of so tangent. Hold on a second. Uh, Yeah, I'm going too fast. Yeah, so and sine t and then minus sine t cosine t. Yeah, so okay. Tangent of t dt. Okay. Oh, that's a minus. Okay. All right. So yeah, I forgot the minus. Of course I did. Okay. So C1 is the minus. Okay. So yeah, don't forget the minus sign in front of C1. All right. So this here, this integral would equal to the natural log of the absolute value of cosine t plus a constant. We'll call it delta 1. Delta 1 is the constant. C2 of t, this would equal to the integral of secant t times cosine t over 1 dt. And so this would equal to dt, and this would equal to t plus delta 2. Delta 2, delta 1 are constants. So the solution, yh of t, this can be written out as, so C1 is the natural log of the absolute value of cosine t plus delta 1 times cosine t plus t plus delta 2. Jesus Christ, sine t. So, yeah, so that is your so-called general solution. So we're done here at this point. So delta 1 cosine t plus delta 2 sine t, and then we'll have a plus natural log of the absolute value of cosine t times cosine t plus t sine t. And that's your answer. Okay. So hopefully that made sense. Okay. So here's another example. I want you to work on this too. So here's another one. Try to figure out the general solution of this differential equation. Okay. So pause the video and I want you to solve using the variation of parameters method. Okay, so I assumed you worked on this example. So let's actually work it out ourselves. So first, we need to look at the homogeneous differential equation, right? 4y is 0. Okay. And so the corresponding characteristic equation is r squared plus 4r plus 4 is 0, right? And hopefully you know that is a factorable quadratic, which is r plus 2 squared is 0. Okay. And what we're going to have now is a repeated root of r equals -2. So it has a multiplicity of 2. So what that means is the general solution y of t should look like this. So c1 of t times e to the minus 2t plus c2 of t times t times e to the minus 2t. Since we have a repeated quadratic root here, okay, we have to not forget to add in the t variable. right? So this is what the general solution for the homogeneous differential equation should look like. And then from here, we're going to solve for the function C1 and C2 of t. All right. So, okay. All right. So C1. So C1, this would equal to, so first of all, let me label out what the A number is. So the A number is the coefficient in front of the Y double prime term. So in this case, A is 1, and our function, capital F, is this quantity, right? So e to the minus 2t times ln of t. Okay, so with that information, we'll figure out what the functions C1 and C2 equal to. All right, so we have e to the minus 2t ln of t times so C1, that's y2 of t. So y2, let me label out what y2 of t is. This is y2 of t, and then y1 of t is this quantity here. Okay, so in this case, it's t times e to the minus 2t over. We need to compute the Wronskian. Up next is to compute the Wronskian. Y1 and y2. So that would equal to e to the minus 2t, and then t times e to the minus 2t. And this is negative 2, e to the negative 2t. And this quantity would be e to the minus 2t minus 2t e to the minus 2t by the product rule, right? And so the determinant of that matrix is e to the minus 4t. Oh, God. So that would equal to e to the minus 4t minus 2t e to the minus 4t. And then we'll have a plus 2t e to the minus 4t, which is e to the minus 4t. So this denominator would be 1a times the Wronskian. So we'll have e to the minus 4t dt. Okay. And then C2 is equal to minus e to the minus 2t ln of t times y1 of t e to the minus 2t over e to the minus 4t dt. Okay. All right. So that is the function C1 and C2. All right. So okay, so C1, this would equal to the integral of, so we'll have e to the minus 4t divided by e to the minus 4t. So these quantities will cancel, and we'll get t times ln of t dt. Okay, and so C1, so we're going to do integration by parts. Okay, to solve the integral here. So u is t, oh wait, u is ln of t. U is equal to the natural log of t, and then dv is t dt. du is 1 over t dt. And then v is equal to t squared over 2. Right? And so C1 is equal to, so t squared over 2 ln of t minus 1/2 times t dt. And so this would equal to t squared over 2 ln of t minus t squared over 2 plus a constant, delta 1, let's say. All right, so that is C1, and then C2 is a lot easier. Okay, so C2 is a lot easier. So C2 is a lot easier. And so these quantities will cancel. And then you'll have C2 is equal to the integral of ln of t dt. Okay, so integration by parts again. One over t, and then v is equal to t. This is dt. So C2 is equal to t ln of t. And I'll do a minus, so a minus dt, so that's a minus t plus a delta 2. So that is C2. And so we can actually write out the the general solution for this homogeneous equation. So y of t, this would equal to C1, which is t squared over 2 ln of t minus t squared over 2 plus delta 1 times e to the minus 2t plus C2, which is t ln of t minus t plus delta 2 times t e to the minus 2t. Okay, so that is the general solution. Okay, and so what we will have left over is suffice us write this out in full. So y of t is equal to delta 1 e to the minus 2t plus delta 2 times t e to the minus 2t plus t squared over 2 ln of t e to the minus 2t. I don't need this anymore. Minus t squared, and then I'll have a plus t squared e to the minus 2t ln of t minus t squared e to the minus 2t. Okay. I'm not going to simplify, but really that's just your general solution. Okay. I'll do one more example. Okay. How about this one? So now this time we have 1/2 y double prime plus 2y equals to tangent of 2t minus 1/2 e to the t. Okay. If you want to pause the video because I'm going to solve this right now. We can actually multiply both sides by 2 in this equation, right? And we can rewrite this differential equation as y double prime plus 4y, and this equals to 2 times tangent of 2t minus e to the t. Let me actually write this down here. So yeah, if we multiply both sides by 2, we can rewrite this differential equation as y double prime plus 4y is equal to 2 times tangent of 2t minus e to the t. Okay, it's a lot easier to work with, and we can just make this coefficient to be 1. Okay, so yeah, so that's one way to simplify things a little bit more. So the homogeneous equation, right, we're dealing with is this: y double prime plus 4y is 0. So the characteristic equation corresponds to r squared plus 4 is 0. And so r is equal to plus or minus 2i. Okay. And so our general solution will look like this form: c1 of t times cosine of 2t plus c2 of t times sine of 2t. Okay? The sine of 2t. All right? So now the real work comes in by solving for the constant c1 and c2. Now, this quantity here is y1 of t, and this quantity right here is y2 of t. Okay, the a is 1, and our function this time is this function right here, right? So f of t. So capital F of t is 2 times tangent of 2t minus e to the t. Okay. Times e to the t. Okay. So what we have now, okay, what we need to do is solve for C1 and C2. So C1 is equal to the integral of our f of t minus e to the t times y2. y2 of t is sine 2t. And then that is divided by the Wronskian. So 1 times the Wronskian. So the Wronskian of y1 and y2, this would equal to the determinant of this matrix. Okay, so cosine of 2t and then sine of 2t, negative 2 times sine 2t, and then 2 cosine of 2t. So that would equal to 2 times cosine squared 2t minus negative 2 sine squared 2t, which would equal to 2, right? So this quantity would be 2 times over 2 times dt. So the Wronskian, important note, is 2. That's pretty cool, right? We're going to drop a deuce on this integral. All right, so, okay. I can't believe I said that. All right. So what this equals to is, okay, so, all right, C1, this equals to 1/2 times the integral of, so, okay. So, this is sine squared 2t over cosine 2t. dt minus the integral of e to the t times sine of 2t dt. Okay, so, all right, let me erase some of this stuff here. The important information over there. Okay, so all right. Yeah, so sine squared. Okay. C1 so that is so that's two. Okay, so the first term would be reduced down to over cosine t, 2t, 2t. So if I concentrate on this integral here first, right, I can just use the trig identity. So 1 minus cosine squared t over cosine t, which is equal to secant of t minus cosine t dt. And I believe the integral for secant of t is equal to the natural log plus tangent of t. Okay. And then this is minus cosine. I'm sorry, minus sine plus delta 1. Okay. Well, there will be a plus delta 1. I need to integrate the second term. So the second term, so that is the first one. And so, okay. The second term will involve integration by parts. And so this integral, e to the t sine 2t dt. So if I let u equal sine 2t and then dv as e to the t dt, du is 2 cosine 2t, and then v is equal to e to the t, right? And so this integral will equal to e to the t's times sine 2t minus 2 times the integral of e to the t times cosine t dt. And then we have to do integration by parts again. So u is equal to, cosine 2t. And then v is equal to e to the t dt. dv is minus 2 sine 2t. V is e to the t. So, all right. Okay, so I have the first term. Okay, I'm almost there. I'm almost there. So this would be e to the t sine 2t minus 2 times. So, okay, so e to the t cosine 2t, and then I'll have a a plus 2 times the integral of e to the t times sine 2t, which we had at the start. So if I call this I, this here is equal to I here. And so what that means is I have I is equal to e to the t times sine of 2t minus 2 times e to the t cosine 2t minus 2 times, I'm sorry, 4 times I. It's multiplied by 2, so that is minus 4i. Okay. And so, oh my goodness. So this integral here, so 1/2 e to the t cosine. Okay, so this integral will equal to so 1/5 e to the t sine 2t minus 2/5 e to the t cosine 2t. Oh my God. All right, cool. So all together, C1, so C1 of t, this would equal to the natural log of the absolute value of secant of t plus tangent of t minus sine t plus 1/5 e to the t sine 2t minus 2/5 e to the t cosine 2t plus a constant, delta 1. All right, great. That's C1. All right, first half is done. And then the second half, we just solve for C2, right? We just solve for C2. Let me clean all this crap. All right, so C2. This would equal to negative the integral of the function f. So 2 tangent of 2t minus e to the t times y1 of t. Oh, I'm sorry, that's cosine. Just did that already. I meant cosine. Cosine of 2t. Over a, which is 1, and then so the differential equation I'm concerning about is this one. Minus e to the t, right? So the a is 1 and the Wronskian is 2. So it will be just over 2 dt. Okay. So we'll have minus 1/2 times, so the integral of, so I'll have sine of 2t minus dt minus the integral of e to the t cosine 2t dt. All right. And e to the t cosine 2t, I'm not going to do the work here, but I'll let you work that out for yourself. But C2 of t, this should equal to minus, so minus 1/2 times So that is -1/2 cosine of 2t. So -1/2 cosine 2t minus, so I'll have this integral. So I'll have e to the t cosine 2t over 5 plus 2 times e to the t sine 2t over 5 plus a delta 2. So that is C2. Okay? I'll let you simplify that on your own. But nevertheless, that is the variation of parameters method. And I hope you enjoyed this lesson. So to check problems for comprehension, here are some of these problems I listed out. Hopefully you are enjoying this series so far. If you have questions, please let me know. Otherwise, I'll see you next time.